Okay, so we're over at the lab, and I've gone ahead and installed the molecular spray UHV4i electrospray deposition source, complete with all of its pumping, onto this X-ray photoelectron spectrometer. Just to point out a few things then, we have a scroll pump which is pumping stage 1. We have another scroll pump which is pumping stage 2, and then we're using the coupling T and bellows so that that same scroll pump is back in the turbomolecular pump, which is pumping stage 3. Then we have a gate valve going to the combined analysis and preparation chamber in this particular system, and it's mounted on a portaliner, and I'll get to that in a moment because this is a particularly stringent laser alignment. Now, none of the pumps are on at the moment, and that gives us an opportunity to speed things up with the laser alignment. Now, I've gone ahead and installed the laser in the V block. This is just very simple. You take the T-piece out, put the laser in, but it would be a remarkable coincidence if that laser was aligned with the entrance capillary, and so it's going to take a lot of fiddling around in X and Y and pitch and yaw on the manipulator in order to get the laser to go down through the entrance capillary. Once it does, then we know we're fine, and we're going to be hitting somewhere in the chamber, and then it's just a case of finding that spot on the sample. Now, because none of these pumps are on yet, what we can do is we can remove either the pump from stage 1 or 2 and then look through the pumping port to be able to see the laser. The other thing that I've done is I've swapped out the normal entrance capillary, which normally has an internal diameter of 0.25 millimeters. I've swapped that out temporarily for the 0.5, so that will give us a stronger chance of being able to optimize the position of the laser beam. And then once I know that it's going into the system, I can then swap it for the 0.25 so that we can start the pumps. So here's a close-up of the laser in the V-mount. This is just a very simple swap for the T, just held together with the grub screw. If you've got the more modern platform style, then you'll need to make a bracket that screws into the M4 tapped holes on the platform in order to hold a suitable sized laser. So usually when you're doing a laser alignment of the electrospray source, what you're aiming for is to get the beam to hit the sample near the center, so that you then know where to look with your XPS or your STM. In this case, we have a more stringent alignment procedure because we're setting up for an in situ experiment, and the sample obviously has to sit in the focal plane of the XPS analyzer. We can't move the X-rays because the X-rays have to hit the sample in a spot in that focal plane in front of the analyzer. And so we've mounted it on a portaliner, the electrospray source, because we need the deposition spot to also hit the sample in exactly the same spot as the X-rays, so that we can do an in situ measurement as we're depositing. So for that reason, I'm using a fluorescent sample. Now, this is obviously not necessary for just seeing the laser spot, but it is necessary for me to know where the X-ray spot is in the XPS machine. And then the goal is to be able to see the X-ray spot and the laser spot, and then adjust our portaliner so that we can make sure that both are hitting the sample in the correct place. Okay, so our first task is to make sure that the laser spot is actually going into the system, and as I said, the easiest port to maybe look down is this stage 2, and we can undo this because none of the pumps are currently on. And then I'll turn the laser on and adjust its position until I can see that it's hitting the skimmer cone in the second stage here. If I hadn't already mounted the turbomolecular pump, then this is a much bigger port to be able to look through, and I could put a piece of card down, and so that the laser could hit the piece of card, and then I'd be able to optimize its brightness. But in this first procedure, I just want to make sure that we can get the laser in. I know that this system is aligned, we've already aligned it, and so as soon as we know that it's in here, we should be able to see something on the surface, and then we can use that to optimize it. And of course, before we start pumping, we have to remember to change the entrance capillary back to the 0.25 millimeters, otherwise the pressure will be unnecessarily high in the main system. So looking down through the pumping port of stage 2, I can see a hint of the laser coming through. And I can just adjust the pitch in the yaw, kind of maximize that. It's quite difficult to see, but I know that the laser light is going in, so I would expect to see this now on the sample when we have pumped down and opened the valve. So it's important now to not move the manipulator at all. I will disconnect the power from the laser, but I need everything else to stay in the position that it is here while I'm pumping down, so that when I turn the laser on, I know that it's still going through the entrance capillary. Okay, so I've gone ahead and reconnected the stage 2 pumping port, and I've swapped out the 0.5 yellow banded capillary for the 0.25 blue banded capillary, and I've started the pumps. So while we're waiting for the pumps to pump down to a good enough pressure, I've gone ahead and turned the X-rays on, and if we look through the window, you can see the X-ray spot illuminating on the fluorescent sample. And the goal of this is to get the laser spot of the electrospray to coincide with that X-ray spot, which we know is in the measurement position for the analyzer, and then we can do an in situ measurement. If you don't have this constraint, then all you need to do is make sure that the laser spot is hitting in the center of the sample. Okay, so I'm going to open the valve to the electrospray, and probably going to need a little bit of fine adjustment in order to optimize the laser spot down through the entrance capillary. And now we can see that the laser spot is almost exactly over the fluorescent spot from the X-rays, and I'm very pleased to see that it's not too much of a surprise, because we've done this experiment before and the port aligner itself hasn't actually been moved in the meantime, so this is very much as expected. If that spot was just a little bit off to one side, then I could adjust the port aligner to move the spot so that it coincides with the X-ray spot. But I'm obviously not going to do that because I'm very happy with this position. Okay, let's just close the valve again. Now that we know that everything's aligned, there the spot disappears because it's been cut off by the gate valve. Okay, so the chances are that we're not going to want to do an experiment on a fluorescent sample. In this case, we want to do the deposition onto gold on mica. And because the surface is very reflective, it can be quite difficult to find an angle that you can find the laser spot, in which case we'll just adjust the Z-axis until we can see the laser spot on the tantalum sample clip, which isn't as reflective, and then we can just move from there. So if we move the sample down until we know that it's hitting the sample, and you can just about see it reflecting off the gold 111 surface on mica there. So there you have it, laser aligned molecular spray UHV4i source aligned with the X-ray spot in an XPS machine, ready for an in situ deposition experiment.